Start the recording.
Okay.
Hi everyone, and thank you all for coming. It is my pleasure to introduce Iulia Danciut. She is a neurologist and has recently finished her PhD at BSMS, or defended her PhD at BSMS, although she's left quite a while ago. And she's kindly agreed to talk to us about some of her recent work, looking at the role of interoception in multiple sclerosis and fatigue. So over to you, Iulia.
Hello, everybody, and thank you so much for coming today. It's a bit weird because I don't actually see everybody. So hi, I'm seeing some familiar faces. Hello there. It's the first time I'm presenting after my Viva. I'm very excited to do so. It's been about 2 months, so now forgive me if I have to go back in it. You know, I felt like when I was actually doing it, I went down a rabbit hole. So I came back up. Let's see if I can go back in for half an hour. So I'll try and make it short so that we can have a nice chat afterwards. I think that discussions are the most interesting part. I would like to present you today a main bulk of my research, but we might, depending on your interests, we might go in some direction or the other. So what I'm interested in is fatigue in multiple sclerosis and the role of interoception and metacognition. So I'm just having a problem actually moving. Okay, that's fine. So multiple sclerosis is the most common neurological disease in young adults. So the way it's, the main mechanisms are that the immune system attacks the central nervous system, the brain, the spinal cord, optic nerves, and it's a great cause of disability and employment problems. So it affects people in the prime of their life, when they are thinking of starting a family, they're at the top of the career path. So there are a lot of things here to consider when we talk about it. Now, in terms of the mechanisms, there is a neuroinflammatory side of things in which we see on the MRI these hyper T2 and their hyperintensities. So that's the inflammation side of things. But on the background, there is a neurodegenerative aspect of the disease. Now, this is a whole debate when things happen, how apart or together these go. But depending on how much involvement is from these two mechanisms, historically, it's been divided in a few MS phenotypes. So we have relapsing-remitting multiple sclerosis, which is most of the people fall in this category. So about 85%, first of all, have relapses. So they end on the MRI, we see these neuroinflammatory lesions like the ones here. But then they partially or totally recover clinically, and then they are well for a while, and then they have another episode and so on with partial or total recovery. On the other side, the neurodegenerative side of things is clinically we see a gradual deterioration, although this is very much a discussion in itself. But just to say that this classification was found recently to be too artificial, and we are now trying to actually talk about MS in terms of active disease and not active. So in my study, I just looked at relapsing-remitting patients, and I think that's a plus and a downside. It's a plus because we wanted to keep it very academically clear. We wanted to find answers. On the downside, it's difficult to say how this applies to the progressive patients, but I think this is a very interesting discussion in itself. So in terms of symptoms, basically you can have anything. It's a very wide array depending on which part of the central nervous system is affected. And a very interesting thing I would like to point out is that we talk about symptoms that we can see, and there is this new and very interesting concept of hidden symptoms. So not all of the symptoms are noticeable. So we can not see the fatigue, we cannot see the cognitive problems, the sensory disturbance, sometimes even the visual problems. So a lot of these things are hidden, and my next slide was just going to be an optimistic, but also to draw a bit of a signal here, in the sense that we now have more and more disease-modifying treatments. So it's getting very exciting for a neurologist on one side, on the other side, sometimes difficult to keep up with. So we have these new molecules, these more and more targeted disease-modifying treatments, which means that we are able to keep people well for longer amounts of time, and to push the progression side of things as much as we can. And to be honest, I think this is one of the reasons I fell in love with this field, because when I moved, I did my training in Romania, and when I moved here in the UK, people have a wider array of disease-modifying treatments available to them. And I was seeing neurology patients, young people, staying well, and with the right treatment, being well, and just able to live their lives with what we like to call no evidence of disease activity. So we can't say we cure MS, but this is our goal. Live as if you wouldn't have it, basically. Now, on the one hand, this is great that the disability side of things is being tackled, but on the other side, something very interesting happened, which is all these other symptoms that weren't so obvious before came, the iceberg came to the surface, and we actually saw that even if people can walk well, they are very tired, they can have cognitive problems, and a lot of other things that they weren't in the front line until now. So I think to convince you of how important the subject is, I can, throw numbers at you and, tell you how much percentage of MS people suffer with fatigue and how important it is. But I think the best proof of it is in 2012, MS people were asked to make a list with where would you like money in research to go to? So make a 10 top priority list. Number one was stopping or reversing disability, which it's very important, but it's very difficult to achieve, the reversal side especially. The second one was preventing MS, and the third one, out of all the possible things, was finding effective treatments for fatigue, because in MS, fatigue is a very characteristic aspect, and people can have it many years before actually learning that they have MS. So to this point, we only have NICE only recommends Amantadine as a treatment. It's moderately effective if we are optimistic. So what I say to patients is try it for 3 weeks. If it works, fine. If it doesn't, you can just stop it. There's no, some people respond, some people don't. And even if they do, it's not this major game changer for them. We used to prescribe modafinil, but recently the European Medicine Agency rendered it as, well, you can still prescribe it, but the side effects are more than the benefits. So it's still prescribed in narcolepsy, but not in fatigue, in MS. So the research in this field is mainly hindered, in my opinion, by the fact that it's so difficult to say what fatigue is. So there are so many ways in which we can classify it, and there are so many aspects to consider. So when you do your study, you need to be very focused, but then you lose all the sight from everything else that's happening, or you have to design a very clever study design. And then it's very difficult to compare with other studies because other people have done it differently. So we have primary and secondary MS fatigue. So primary, it's related to the mechanism of MS in itself, but also we have a whole array of fatigue problems related to the medications they're taking, the symptomatic medications, I mean. And MS patients have a lot of other problems with pain, disability, and depression. All these things can either confound or actually cause fatigue. Then we have mental and physical fatigue. So in my study, I focused on the cognitive side of fatigue. I took a peek at the physical side as well because I was too curious. But I thought it's important to go in on one way and see exactly what's there. Then a whole other discussion is around how do we actually measure fatigue, so you can have subjective and objective fatigue. And one could argue that unless you prove it, how do you know it's there? If it's just a questionnaire, how relevant is it? There are some very interesting ways in which people have designed measuring fatigue. For example, they measure it before and after a tiring task, or they have all sorts of things in which they do it. But I think the problem is the fatigue that actually bothers people and changes their quality of life is the feeling of fatigue. This subjective problem. So the nature of fatigue itself is subjective, it's a feeling. And this prompted me to go in the direction of looking at interoception, because I was very interested to see how does the feeling of fatigue arise. So then the other discussion is, do we measure state or trait fatigue? So for example, I used questionnaires asking them how tired were you in the past 4 weeks. So if we were to have done an MRI study, an fMRI study looking at fatigue in the moment, that would have been a different approach. So it's different types of fatigue can mean different things and can have different substrates. So I guess just to summarize a bit about fatigue, is this hidden symptom, multidimensional concept. And very interestingly, it doesn't really mirror the relapses, in the sense that if I see a patient with he tells me nothing else is wrong, but he has very severe fatigue, I might suspect that they do have a clinical relapse, and I might actually scan them if I'm really worried. But the other way around is not true. So actually, we have a lot of people who we know, and we've seen even the imaging, and we know that nothing is going on actively, but still they're tired. So there is this background of fatigue. So, and also the same with when they start disease modifying treatments, some people say they feel better, but some really don't. So it's not that when you treat the neuroinflammation side of things that the fatigue goes away. And it doesn't clearly parallel disability either. So there are some studies showing that the more the disability, the more fatigue. And I guess for physical fatigue, that's a reasonable thing to consider. But there are exactly the same amount of studies who showed the opposite. So we don't have a consensus. And the other thing is that for neural correlates, so a lot of people have been very interested to see, okay, what's happening in the brain, because we have this unique opportunity to see with neuroimaging what's actually going on in the brain, and it's like the next step of our journey. So I just wanted to say, I know this has nothing to do with fatigue in itself, but I thought it's really interesting, and it gives us a bit of hope to know that there is another domain, just as subjective, which is pain, in which you can't really go any way around it other than ask people what their pain levels are. Of course, you can do all of interesting things to test, and try and make it more objective. But in the end, it's what the people say it is as a feeling. So a lot of progress has been made in a pain field. So they now have characterized central and peripheral mechanisms, described the network. clarify the difference between acute and chronic. So for us, it would be state and trait fatigue, and try to disentangle which types of pain are due to central or peripheral mechanisms. So then another question which I always ask myself is, in the end, is fatigue friend or an enemy? Because we have this evolutionary role of fatigue. So it should help us adapt and let us know when to rest and to stop what we are doing so that we can preserve our resources. But I think the main difference is when people with MS say, oh, I'm fatigued, they hear their family, their friends, their coworkers saying, oh, I'm so fatigued too. And it's really important to raise awareness that is not the same thing. So we are talking about pathological fatigue. That means there is no adaptive function. Of course, if you do more, you will be more tired, but it doesn't mean that if you do less, you will be less tired. That's the thing. So it's not alleviated by rest or sleep and is not proportional to the degree of activity. So when people try to look at the imaging side of things, the first thought, I'm sure you've thought of this as well, was if people have more MS lesions, more brain lesions, or that disease activity is more clear on the MRI, does it mean that they have more fatigue? So the answer is no. And it's not a universal answer. So there are some studies which showed positive results, significant results, but it's not true for global higher lesion load. So it's, if you look at specific regions, then we might talk about, if there are more lesions in specific regions, it might be true, but not for the whole brain. So the current hypotheses in this field are very exciting. Dopamine imbalance theory. So the brain looking at measuring the level of cost and benefit. It kind of says it's not worth it to do it. So fatigue as a miscalculation of cost and benefit. Actually, I tried here to depict some of the, a small literature review just to depict what areas are involved. And basically, if you look at it, it's just a list of, it's all the brain, really. So when I try to do a more, to triage them and say, okay, this study had small sample size, this study have this, but to be honest, it's such a big heterogeneity in how the studies were done, what they used, how they measured fatigue, what areas they looked at. So it's almost like there is this network, and I think this is where things are going now, more towards the fatigue network view. So the problem with these studies is that they are not hypothesis driven. So if I go to look for something, it's one thing, but to have a hypothesis and then test it, I've had a really difficult time to find such a study. So then from the angle I wanted to take was to look at fatigue from the interoception point of view. And I came this very interesting concept of interoception and metacognition. I know some of the people here are interoception experts, so I won't talk much about it, just to say, for I don't know if there are students here or people who haven't really worked in this field. So interoception refers to the information that the brain gets about the internal part of the internal body. And Sarah Garfinkel described 3 interoceptive domains. So we talk about interceptive accuracy, which refers to how well people perform an interceptive tasks, and this describes a bottom-up processing. So how accurately is the brain informed about what's going on inside the body? Then we have a top-down pathway, with interoceptive awareness, in which this is a concept actually referring to how confidence about one's performance matches the accuracy at interoceptive tasks. And there is also this subjective dimension of interoceptive sensibility, in which we ask people how do they rate themselves generally, so not related to a certain task, but how do they generally think they score, how in touch are you with your body. And then there is this whole list of bodily things to consider when they score themselves. So then another very interesting and relevant concept I came across was the concept of metacognition. So for example, when we talked about interoceptive awareness, that was the metacognitive aspect of interoception. So metacognition refers to how the brain self-evaluates its own performance, and it can be related to specific domains, or we can talk about metacognitive abilities in general. And this is a whole discussion, much like we have, for example, with intelligence. Is intelligence a global thing, or is it related to specific domains? So, and again, I just wanted to underline that we have interoceptive accuracy, awareness, and sensibility, and the awareness is the metacognitive aspect of interoception. So Stefan Klaas had a very interesting paper in 2019 about how these things could come together, in the sense that actually fatigue in MS included could be related to a problem with metacognition. And this is very interesting because it's like taking it to another level. So far until him, it was looked at from the bottom-up point of view. So we have some discussion about the hypothalamus, from the relationship between the brainstem and the hypothalamus, and how things could go from the bottom to the top. But actually, he kind of flipped the pyramid, and he opened the discussion about how metacognition could play a role in this. So this is why when I designed my study hypothesis, I said, well, it's difficult to, that's the question. How does it go, bottom up or top down? So here in the table in the left, it's how I put the interoceptive accuracy, awareness, and general metacognition. And I had my first hypothesis, which was actually, it's reasonable to think that MS is, you have inflammation, then it goes away, it comes back again. It could be that in between the episodes, the interoceptive pathways remain activated, and they convey the wrong information to the brain. It's like they're telling the brain that something is still going on in the body when it's not. So this was a reasonable thing to test. And we have some groups, for example, Andrew Lloyd in Australia, he was looking at the same thing, but with post-infectious fatigue. So there was some evidence that in post-infectious fatigue people, there was a hyperactivation of the interoceptive pathway. So I think he used the interoceptive discrimination task, the heartbeat discrimination task. So he, it's something that I was interesting to test, but if that hypothesis were to be true, it means that I would have found low interoceptive accuracy in MS fatigued people, but not in the non-fatigued people, and that the other would have been not, I wouldn't have found any significant results with the awareness and the general metacognition. The second hypothesis was the opposite. It was a top-down interoceptive hypothesis, but confined only to the awareness. So if I were to find that interoceptive awareness was affected in MS fatigued patients compared to non-fatigued ones, then, but not in the general metacognition then it would have been hypothesis number 2 to be confirmed. And then the third one was, if hypothesis number 3 of general metacognitive abilities impaired in MS fatigue would have been true, it would have meant that I would have found low interoceptive awareness, and the general metacognitive side of things would have been impaired. So these are the 3 things I've tested. And in order to test it, I designed the MS-FIN study, which happened at CISC before COVID, thank God. So we were able to recruit, this is the website, to make it more appealing to people, and Samira and myself posing for the general public. So we had a lot of the support from the neurology consultants, from Dr. Wakar Rashid and Dr. Marco Bosali. So we wouldn't have been able to do it without them, and the whole MS team. So in the end, this was how it was done. So we had 71 participants who came. First of all, we pre-screened a lot more. So the telephone pre-screening was useful because I had a very difficult inclusion-exclusion criteria list. So it was easy to exclude things, so that I wouldn't, these people are fatigued, I wouldn't want them to come unless they really have to. And I just wanted to mention all the people who came to the study. I think it's amazing that they are, they suffer with this disease. Some of them suffer with fatigue, and they really took their time to come for 2 visits. So first of all, the screening process happened, and then they had some questionnaires and the behavioral tasks. And then in another visit, they have the behavioral tasks. So the tasks are the ones used as Sackler Center. So I did both heartbeat tracking and detection tasks. And they had structural and functional, resting state functional MRI, but my work only focused on the structural bits. So that's what I focused on. And then they had questionnaires. Some of them were to characterize fatigue. And I think it's very important that the other ones were because we had to exclude people with confounding factors. And we had to very carefully characterize our population in order to find relevant results. So for the people who don't know what the tasks are involving, so first of all, the interoceptive tasks. So we measured interoceptive accuracy with a heartbeat tracking task. So they had a pulse oximeter on their finger, and they had to silently count the number of heartbeats in a specific interval. And they heard start and stop. And then how we actually measure the awareness side of things. Afterwards, they had to rate themselves on a VAS scale and say how confident they are in the results. And then we measured what the difference is between their actual performance and how they rated themselves. How basically the question was, how well do they know if they're doing well, or how, even if they're doing poorly, do they know that they're doing poorly? That would have meant a high awareness still. For the discrimination or detection task, they again had the pulse oximeter, and they heard some tones, so they had to say if they thought they were in or out of sync with their heartbeats. Then again, the second part was to actually rate themselves in their confidence in the response. So these are the interoceptive tasks, and it was very important in order to see if MS fatigue is related to a pure interoceptive metacognitive problem or not. It was very important to have some metacognitive tasks that are completely unrelated. So we did visual perception and memory. So in visual perception, they saw, we got these tasks from Stephen Fleming. Very grateful that he allowed us to use them. So in the first one, they saw 2 circles, and they had to say which the left or right had more dots. And it was made in such a way that it wouldn't have mattered how much, how good they were, because some people performed very well and some people not. But it was scaled in such a way that if they weren't very good, then it would get easier for them and the other way around. After they rated how they thought, which ones they thought had more dots, they then rated themselves at these tasks, and they had 200 trials at this one. So for the other one, for the memory task, they saw a list of 50 words in a short amount of time, between 30 seconds and 1.5 minutes. And then they were presented with 2 words, and they had to choose which one do you think was on the previous list. So again, quite a challenging one, but it was tailored to their performance, and they rated their how well they thought they performed. So the questionnaires that we performed are except for the fatigue ones. So the fatigue ones are the main one that we use is the modified fatigue impact scale, which I chose because it has the possibility to disentangle cognitive from physical fatigue, and I thought that's really important. We also did a fatigue severity scale because it's very used in studies and in MRI studies, so we wanted to have that possibility to compare. And then for the depression and sleepiness, which are major confounders for fatigue, we excluded people with over a certain number. So for just to make sure that we keep only people who aren't too sleepy or too depressed. And we measured, cognition and quality of life and a few other things. So with the MRI, so we did the structural side of things. We did a diffusion tensor imaging, and particularly looking to see fractional anisotropy. And we used advanced techniques in which my supervisor, Mara Tertignani, is an expert. So I was very happy to work with her and to learn about these very interesting techniques. So Neurite orientation, dispersion, and density imaging, and NODDI, which has the benefit of looking at the microstructure of white matter, because it's, we were interested in the white matter, but microstructure in general, because it separates compartments. So we looked at Neurite density, orientation, and dispersion, and isotropic fraction, with more interest in the first two, because it's relevant for what we were interested in. And then we also looked at quantitative magnetization transfer as a proxy measure of inflammation. So again, this is a whole discussion whether it's related to myelination. So myelin, of course, playing a role. So this is just from Charlotte's Ray. Sorry, it's not a very good resolution. So just to show the different compartments in the NODDI technique. I'm sure a lot of you are familiar with this, so I won't get into detail. I just wanted to say that I felt very good about, a lot of research was done with NODDI recently, a lot of interest in it, and I was very happy to do it in an area that it wasn't looked with before. So nobody looked at MS fatigue with NODDI, so that was a very interesting one for me. So the numbers with the results, so we had 71 participants in the end, only 69 had MRIs, which I think it's a good number for MRI studies. And some of the metacognition tasks we had a bit less, but I think it's still 66 is the worst I got. And in terms of our results, so the people who participated, interestingly, weren't extremely disabled, so that it was more towards the non-disabled. So the median EDSS is the scale we use in MS, and it goes from 0 to 10, where 10 is death and 0 is no disability at all. It would be completely normal. So disabilities mainly starts, more disability starts from 3, and with 4 we already have walking problems, and beyond 6.5 it's already wheelchair. bound. So in our cohort, I think it's very nice that we had patients who weren't very disabled. So if they had fatigue, it wasn't because this is ongoing discussion how much of it is related to fatigue. However, we did find that the fatigued people did have more disability even within this low disability cohort. These are people who were, some of them weren't taken any disease modifying treatments, some were on moderately effective disease modifying treatments, and some were on high effective treatments. So as much as possible, I was trying to see how we can keep the balance. And I think it's nicely achieved. So this is the fatigued, non-fatigued table. So people in the first column are with a modified fatigue impact scale under 16, and the other one is over 16. Now, why we chose 16? I couldn't find any clear literature because it was mainly used modified fatigue impact scale in total. So there wasn't a clear cutoff for fatigue, for cognitive fatigue. So we used the median. But what I did was I found a study with about 400 MS patients from Boston, and they had used the same scale. So I emailed them and I asked them how many of them are relapsing remitting. And I found that their fatigue cutoff was around 12. So then it kind of oriented us towards our group. So I went for 16, and I including the 4 patients who had the number 16 as fatigued, informed by the Boston study. So I think it's interesting that if we look here at, I was mainly interested in what it would show at disease modifying treatments, and it was evenly distributed. We did a chi-square test. The EDSS is higher, so the disability is higher in the fatigued patients, and this is, I think, it just reflects what really happens, the real population data. They did have more depression, but again, I would like to underline that these people weren't clinically depressed. So the people with higher fatigue were more depressed, but with low depression levels. And again, I was interested in anxiety because we have evidence of interoception and anxiety interacting with each other. So the higher, with low interoceptive accuracy and high interoceptive sensibility, so what we call interoceptive predictive error, higher in people with high anxiety in certain diseases such as autism. But still, it was an interaction I was going to consider. So it's close to significance. I don't know if we had more a bigger sample size, what would have happened, but this is how we found what we found. So the other ones were evenly balanced. So this is the behavioral result for cognitive fatigue. So I use logistic regression, and the reason why I use logistic regression and nonlinear regression is because it wouldn't have really mattered in terms of going up or down one step or lower on the fatigue scale. What I was interested in was to see how do they interact between each other. So what I found is that the odds of having high cognitive fatigue are higher in the low interoceptive tracking awareness group. So this is very interesting because I haven't found the same results in the detection group. So in the, we did 2 tasks. And I think this is an interesting discussion in itself. But one could argue that actually the tracking one is measuring pure interoception, because for the detection one, you have to also listen to the sound, and it's a different stimuli. So the people who are doing the tracking task were just concentrating on their own bodies when they were doing the task. So looking at these results, nothing significant was found for the other metacognitive tasks. So the general metacognitive top-down hypothesis was rejected. I didn't find any relationship with the accuracy side of things. So then the bottom-up hypothesis was rejected. So this result confirmed the top-down hypothesis, but confined to interoception. And so this one on the left is for just when I accounted for the tracking awareness and the fatigue, the cognitive fatigue. And this one on the right was when I actually accounted for the confounding factors. So these were anxiety, depression, disability, age. So I think, the results stood the test. I didn't put it here because I thought it would be too much of a spread, but when I looked at the physical fatigue side of things, I found a similar result. It was significant, but when I actually accounted for the confounding factors, it didn't survive. So it didn't remain significant. So this confirms the top-down hypothesis, and then informed by the behavioral results, I went on and did track-based spatial statistics analysis, looking at the white matter, so specifically looking at the white matter skeleton with this TBSS analysis, because this is what we were interested in MS. So just to show you here, this is a very general overview of everything that we found, but then I'll get into details. But first of all, here on the left, I just wanted to see if people with more fatigue had lower integrity of their white matter tracts. So I found an inverse correlation between the FA and FICVF. This is the Neurite density side of things. But only when I accounted for covariates, I used these covariates, disability, depression, and disease duration, because these were the game changers when I looked at the univariate analysis. So I only found significant results that survived for the Neurite density. And then I also looked at the interaction between the imaging parameters and the cognitive fatigue in the groups with high and low tracking awareness. So in this group, I found the same, the fractional anisotropy and Neurite density index, and they survived when I did the covariates. But it's very interesting because these results these are the qMTi parameters, the quantitative magnetization transfer parameters. They were significant, but they didn't survive when I actually, they didn't maintain significance when I actually accounted for the disability, depression, and disease duration. So I don't know, maybe if we had a bigger sample size, what would have happened with them. And I think this is an interesting discussion because it could mean that if these are not so much involved, it could mean that it's not so much about neuroinflammation, but mainly about axonal loss side of things in MS. So I'm not sure if I tried to make them easy to see by putting them all together. I'm not sure if it was such a good idea, but the red, the ones, so the green is the white matter skeleton, is just the background skeleton in just to help us see where the skeleton is. Now the red and yellow bits are the significant results that we found in people with considering both MS lesions and normal appearing white matter. And when you look, for example, at this one, But when you look at the other one on the right side, the blue ones are if we just look at the normally appearing white matter. So we applied a mask to take out a probability mask of taking out the lesions. So then, of course, the discussion was if the lesions were there, then was it because of lesions or not? So, but you see, even after applying the mask, it's still a bilateral widespread white matter network. So I found an inverse correlation between the cognitive fatigue and here in the first picture, FA, in a bilateral widespread network. That means that the integrity of the white matter was lower in people with higher fatigue, cognitive fatigue. So then now we can ask ourselves, integrity of white matter meaning what? Is it because they're not so much, so the density side of things, there are not so much fibers that kept integrity, or could it be because of the way they are dispersed? Because if they're more dispersed, it would look like the FA is lower. So this is where NODDI comes handy, because it gives us this answer actually. So if you look at the third picture here on the right up corner, this one is for the NDI. It means that the widespread bilateral white matter impairment was because of the density in itself. And I didn't find any significant results for the orientation dispersion. So it means that the FA results here are based on the density side of things rather than the dispersion side of things. And then again, here on the left down, it's about the same thing, but only looking at the normal appearing white matter. And then I tried to do, I did the analysis again, but looking for covariates. So we have a few areas that's less than before, but still a few things to consider. Okay, sorry. So then the next thing we did was look at the interaction. So I think maybe it's easier if I just show the next slide. I kept on the right side because I know it's difficult to so, I just kept the same thing I showed you before. So we are now here at a table. Sorry, I left here table 17. So here is a table with the significant interaction results. So with interaction, it's difficult to say. It's more of, let's see where things are going. It is informed by what we saw before. So I did look at the interaction between cognitive fatigue and the tracking awareness, because we knew tracking awareness was the one which we found significant in the with the behavioral results. I do acknowledge that this is not very much hypothesis driven in the sense that I didn't have a strong hypothesis what the interaction would show. It's difficult to say what it means, and I think this is one of the nice discussions I wanted to actually pick your brains about. So, for example, if we look at the FA, so we see that people with high tracking awareness, which are the ones in blue, they have the lower. No, sorry, let's look at the red line first. So for the red line, the people with low tracking awareness, the higher the cognitive fatigue, the lower the FA. So the higher the fatigue, the lower the integrity of the white matter, which makes sense to me. Now, if you look the other way around, what happens to the people with high tracking awareness? For them, it seems to be the other way around. So the high tracking awareness people have, the more fatigue they have, the more we find integrity in their white matter tracts. And this is, we found the same thing for the Neurite density index and for the for the qMTi parameters F and Kf. Now, why that is, I wouldn't be able to pinpoint to it. I had very interesting discussions, and one of the suggestions was that could it be that actually if you have more integrity in your white matter, you could actually feel more if you had fatigue, because you have the means to. So, and now let me just show you the areas, because I haven't shown you what the actual areas were. So for the interaction, again, it's a widespread white matter network. It involves cingulates. It involves so the ones on the left with yellow and red are here are the NDI results for the normal appearing white matter and for the both normal appearing white matter and MS lesions. Sorry. So the one on the right, up right here is it's these ones, the three ones below and the one on the right are the quantitative magnetization transfer parameters, which they didn't survive. Sorry, they didn't survive when I actually looked at the covariates. So as a conclusion, interoceptive awareness, but not accuracy or general other metacognitive abilities, is associated with higher odds of high cognitive fatigue in MS patients. And this is after considering covariates. And this confirms the top-down hypothesis confined to interoception. And we used diffusion, tensor imaging, NODDI, and qMTi to characterize the relationship between the white matter and cognitive fatigue. And we found a bilateral widespread network to be related to MS fatigue. And the next question is whether interoceptive awareness training could be a potential therapeutical target. I think it's a very interesting discussion to ask what that would mean, because as far as I know, interoceptive training is currently referring to the interoceptive accuracy side of things, and the awareness side is not something that was trained until now, as far as I know. Now there is another thing with metacognitive training, which people have designed metacognitive training aspects, but then again, I think it would be nice to hear from you if you have any suggestions about other things. So just to talk a bit about why I think the study was different from other studies. So we had a hypothesis-driven approach. We used the advanced MRI techniques and we combined them with a behavioral analysis, and one informed the other. The using of TBSS to look exactly at the white matter skeleton, and the design of the study itself was very difficult to do, to actually exclude a lot of the confounders, but also keep our track on what we were looking for, and also make it generalizable as much as possible. I think we had a good sample size of 71, but I'm very excited to see how these results will be replicated with higher sample sizes. And we looked specifically at cognitive fatigue, but I think it's very interesting how physical fatigue can play a role in this. So we used a 1.5 Tesla, that's one of the limitations, and this is a cross-sectional study. I think nowadays we can even think for future to look at apps to rate, so people could rate their fatigue every day for a few times a day for a certain amount of time, and then we'll be able to look at state and trait fatigue. I think that would be very nice. I think this was already done, but not necessarily for fatigue, but people, are doing these kinds of studies, and I think it would be a step forward. I think there is definitely a selection bias in the sense that if you're really tired, are you really going to come to a fatigue study? So then the other thing is, I think we were reluctant to ask people who were just newly diagnosed, they were still processing. But I think we got a good range of patients with different, different points in their MS journey. I haven't included MS progressive patients, and I think this is one of the very interesting things to see, because it's the same disease. We just talk about different amounts of how the mechanisms of it play together. The MS, MFIs and FSS are not specific for MS, so we tried to, as much as possible, to exclude any confounders, because people could score high on these because of other problems. And we didn't measure fatigue objectively, and we did measure trait fatigue, I meant to say, trait fatigue over the last 4 weeks. Future directions, we have fMRI data. It would be nice to do study on the 3T MRI, and to use some objective testing as well, and to have interoceptive awareness training. So it would be nice to also add the component of, okay, what can we do with the things that we know? Is this something that's worth exploring? And of course, I'm very curious to see what a bigger sample size would tell about our results. So I would like to thank from the bottom of my heart to my supervisors, and just to say, I did all this before COVID, so I can't imagine what people are going through without it, but you have been really amazing. I had a really, really good time in Brighton. I'm sorry I had to leave, but I hope we can stay in touch, and thank you very, very much for listening.
Thank you very much, Iulia. It's very fascinating stuff. So I'm conscious we're already at 2 o'clock, but if people want to ask questions, or by all means, I'm happy to leave the Zoom up and we can have a discussion. But if people need to go, then by all means. Does anybody have one question? Okay, we've got a question in the chat. So this is from Sam. The interactions between MS status, fatigue, and white matter parameters is interesting, but looking at your scatter plots, it seems as if there may be a little thank you, Sam, heteroscedasticity in the data, i.e. variance and the outcome is not independent of your predictors. Have you looked to see if the relationships are robust in the models that do not rely on homoscedasticity as an assumption? I should have made you read that yourself, Sam.
I'm having a difficult time. I can't see anything.
If you click on the Zoom window, there's a chat.
Yeah.
And then you'll see the
but I think I know what the question is. Yeah. I thought about it on myself. maybe not as accurately put, but yeah. So I think, yeah, absolutely, you're right. And I think there are a lot of ways to test this. First of all, I don't know, again, I think they're all pointing towards the same thing. So that's why I left them, because I thought it's, we tested different types of, there are different MRI parameters and they're all showing the same thing, even though it is a bit scattered there. But yeah, I mean, I would be curious what other tests you would consider. I'm, I thought of a few, but would you suggest anything in particular? Sorry, I don't see anybody again. I don't know.
Yeah, he said just a sec. I'm sure he'll write something in the chat. Oh, he's getting a microphone. Briefly, I will ask you a quick question. So this is a more general question about MS. I don't know very much about the disease. Do people with this disease respond to kind of like exercise-based interventions, like, you know, like in a normal healthy individual, the level of fatigue you feel can be affected by, you know, you can do training and gradually increase your work capacity. And is that, do MS patients respond to that kind of thing, or does that just not work for them?
No, it does. So we have, sorry, I just talked about the pharmacological interventions. We have a whole realm of non-pharmacological interventions, and some are robust studies. So, you know, some of them are recommended by NICE. So when you look at the NICE guidelines, we have 3 categories. So we have non-pharmacological pure exercise, like, you know, I don't know, Tai Chi, yoga, sort of things like that. You have pure psychological interventions like CBT or things like this. And then there is an approach of combining them together. So that's the third option. And that's the one that was shown to be the most effective. So we have a few very robust trials. We have a, I don't know if you've heard of FACETS. It's from the University of Southampton, I think. So it's so people participate in this. It's a course in which they learn. So and you know, they get engaged with both the physical and the psychological aspect of it, and they go step by step. And it's also, you know, they're also learning about it. You know, like they are given these red, amber, and green kind of cues, and to see where you are now and see how to pace yourself and so on. But also they have to do the exercises and to engage in SPT. So that was one of the successful ones, and the MS Society has picked up on this, and they are organizing now. They used to do, the MS nurses used to do face-to-face groups, because, you know, it's nice for them to have the social interaction as well. With the COVID now, I've seen that they've put web on, how do you say, you know, just an online course for them. So these are the ones that were shown. Now, it's interesting if you think about the physical side of things, you know, to see on account of what would that be. And, you know, there is data to suggest that it is useful, but it's, you know, it's not life-changing. So it's, you know, it's better than.
Yeah. Thank you. Yeah, I just wondered if it was something that just didn't work for them. Yeah, thank you.
No, it does work, and yeah, you know, it's not just subjective. It's been studied, so there's been a lot of interest in this area, of course. So there are a few more, but they have the same kind of pattern. So they looked for both the physical and the psychological side of things. And when I say psychological, you know, it's a whole thing here, because then we have to disentangle fatigue not only from depression, but of course from apathy and other aspects. Sorry.
So Sam, did you have something to add about the heterosclerosis? I'm not even going to try.
I'm not going to say either. No, Mara has just mentioned something in the chat that you did permutation tests. I apologize. I came late to your talk, so I missed the very beginning bit of it. I missed that. So yeah, permutation test. The sampling distribution would be estimated from the data. So you I guess it somewhat alleviates my concern. But I think as Mara said, like sometimes it's still it's something to watch out for. But I think there are some models that can like explicitly explicitly like account for the fact that variance in your outcome increases as one of the predictor decreases or increases in value. Maybe it's something to check out for. I don't know. I was just thinking, like it's an interesting little set of interactions. It seems consistent like across different measures as well.
Yeah.
It's unusual. I wonder, like just out of interest, have you tried looking to see whether you can fit like I guess it would, but like a parabola to it, like, you know, rather than having two separate groups, is it well described by, I mean, it would be because I saw the shape of them. So it's a bit of a silly thing to suggest, but yeah, I don't know. I'm talking nonsense now. Ignore me.
The other suggestion I got at some point was to try and do Bayesian statistics to see if it's, you know, so, you know, I think there are a lot of things I could do if only I had, you know, if only I hadn't finished, but I'm still curious about a lot of things. And I think the more you talk to people, the more ideas you have. So yeah, thank you.
No, but very interesting. Thank you very much.
Thank you.
Yes, thank you very much, Iulia.
Sorry, I was going to speak half an hour. I don't know what happened.
That's impressive.
Thank you for staying with me, and sorry for keeping you so long. I forgot how much I missed this, so I just kept.
No, it's a very fascinating, engaging talk, and quite a topic I don't get to hear about very often. So great.
Thank you so much for inviting me, and thank you for everybody. I see Nick here. Hi, Nick. Thank you for all your help.
Oh, David, Iulia, can you see the chat, Iulia?
Yeah, I can now. Yeah.
You can email me about it. We don't need to. We can discuss it after we've closed or whatever. The HADS is very popular because it's short, but it's confounded with mood. Presence of bad mood should be balanced with absence of good mood, and it isn't. Most of the depression items are people complaining that they never have anything good in their feelings, which is different from complaining because you're always having bad things in your current feelings.
Yeah.
I don't think it matters for the fundamental orientation of the psychological side, subjective side, as you call it. But if you get into the details of trying to manage their mental states,
yeah,
probably does matter.
I know what you mean. I was trying to find one that, first of all, is validated in MS. You know, second of all, like you said, is short, but also to, you know, it would have to be something that was used before in other studies, and it just seemed like a good choice. But yeah, what would you have suggested, just out of?
I don't know. There's an Edinburgh, I think, anxiety and depression modification of HADS, but I haven't examined it closely. We've fiddled with the items and have got a mood valence balanced.
Yeah.
But we haven't used it or validated it. There's also the PANAS has anxiety and depression specific items, as well as the positive affect, negative affect polarity, or use short versions of anxiety specific and depression specific scales, you know, like the Spielberger and Beck.
Yeah, I think for me it was maybe.
I have no idea which are validated in MS.
Yeah.
Other fatigue conditions.
I've seen the Beck's one in MS. Yeah, I think in the end it was just a matter of finding one that is mostly used, but maybe, you know, I'm perpetuating the same mistake. Yeah.
And your hypothesis about the role of anxiety is very interesting. You know, it's just not another worry. Works quite differently from gloom.
Yeah, and I also find
chronic disease is very understandable.
I also found, I haven't spoken about this because I thought it's too long, but I looked at the quality of life with 3 scales. And, you know, the more fatigue they had, the more impaired the quality of life, of course, except when I use the UseMS scale, which is looking at self-efficacy. So there are a lot of discussions whether fatigue is a self-efficacy problem, you know, like, oh, I can't do this because I know I can't do it and so on. But in my case, I didn't find this. So people who had or didn't have fatigue have the same self-efficacy results. So for me, that was really important because it was one of the things that's mostly talked when you know, when fatigue comes in discussion, especially, oh, it's a psychological thing, it's self-efficacy and so on. So in these patients, it wasn't. So that was very consistent. So I thought that's very interesting.
Yes, it is.
Sorry, we don't hear you, Chris.
Yes, thank you very much again, Iulia, and I will upload this to the Sussex Neuroscience YouTube channel, and I'll send you the link so that you can, you know, if you have anyone else you'd like to share it with.
Thank you.
And yeah, very nice to meet you. And yes,
Nice to meet you too, and thank you all for coming.
Thank you.
Bye-bye. Bye, everybody.
bye-bye. So I'm actually going to meet with Jamie right now on this link. So.
Yeah, Georgios might not be there, so you're going to have to kick him out. Hugo was there, but he's disappeared. Did he reply to your email?
He did, yeah. So hang on. Actually, let me stop the recording as well.